In this time, one of them completes three and the other completes four revolutions. Again, this is an important piece of information. If I extend this line, this angle becomes theta and this angle becomes phi minus theta. But their motion is not along that direction. This is question number 19. It says that two balls A and B are simultaneously released in two frictionless planes. Imagine a situation in which this ball is not there. And so in this question, there are two students who simultaneously start from the same place on a circular track and run for 2 minutes. Okay, so keep that in mind. In this time, one of them completes three and the other completes four revolutions. Again, this is an important piece of information. Due to thick vegetation in a circular area shown in the figure, either of the boys can see only one third of the track. Okay. How long during their run do they remain visible to each other? All right. Now, what are the important points to notice here? Firstly, they run for 2 minutes, and the question tells us that the in this duration, one completes three revolution and the other completes four, which basically means if I write omega one as 3 into 2 pi radian divided by 2 minutes. Okay, so the omega one that I get, that is 3 pi radian per minute. Okay, similarly, if I want to write omega 2, is instead of this 3, we will have a 4. So we will end up with 4 pi radian per minute. So this is the angular speeds at which the students, they are running around in the circular track. Now, let me draw an aerial view of the circular track. So let this be the aerial view of the circular track. All right, and also keep in mind that no one has eyes at the back. Okay, so a person can see the other person only when the other person is in front of the first person. Okay, so with that in mind, let's say both start from here. Okay, let's say A and B, they both start from here. They start going around the circle like this, and let's say B moves faster. Okay, so after some time, we will find B ahead of A. We will find B ahead of A, and A will be able to see B so long as the angle between these two radii, the angle between these two radii, let me call this as RB, let me call this as RA. The angle is less than 120 degree. Why 120 degree? Because the question tells us that they can only see each other on one third of the track. So that's 120 degree. All right, or 2 pi by 3 radians. Okay, so how do I write this angle? This angle will be, you can check this, it would be omega 2 into t minus omega 1 into t. So that would be the value of this angle. And if I put the values of omega 2 and omega 1, we end up writing pi t. So this angle is pi t. Okay, so this angle is pi t. So if I now want to see that when B comes around and joins A again at some point in time, in that motion, which motion? When B goes around A and joins back A, in that motion, till how many minutes was A able to see B because B went ahead of A? Okay, so how we will get that? So let me write that time as capital T1. So capital T1 will be given by equating this value to 2 pi by 3. Okay, so the t that you get from here will represent t1. So that would be 2 by third of a minute. Okay, 2 by third of a minute. So as B goes around A and joins A again, A is able to see B for a duration of 2 by 3 minutes, which is equal to 40 seconds. Okay, now let me calculate we have been told that the motion continued for 2 minutes. Let me calculate that in 2 minutes, how many such events can happen? What kind of event? When B goes around and joins back A. All right. So I will calculate T2. T2 is the time period. Okay. It is the time in which B joins A again. B catches A from behind. Okay. For first time. Okay. For first time after start of motion. Okay, so how much will that be? So that will be given when this angle omega t, when this angle becomes equal to 2 pi radian. So I will write pi into t2 is equals to 2 pi. So t2 will be equal to 2 minutes. Okay, which is exactly the duration given to us. So what we can say is that the duration given to us is the same duration in which B just goes around and catches A from behind for once. So during this journey, B was visible to A, or B stayed in front of A, and B was visible to A for a period of 40 seconds. So 40 seconds should be the answer here. So the answer to this question should be option B. All right, I hope you got that, students. So the answer is given to be B, and that would be the correct answer. Now, this question, question number 17, it is based on our understanding of what tangential velocity or what tangential acceleration and what normal acceleration mean. Okay, so the situation is given here. Let me redraw the situation here. Okay, so the particle may be somewhere here. Okay, and this is the position vector of the particle. This is the position vector of the particle, and this is the angular position of the particle. So this is position vector. Now, guys, before we start checking out the option, I would like you to pay attention to a certain case which will be helpful for us in figuring out the right options in this question. So let us consider a situation in which the particle will move on a straight line. So if this particle starts moving on a straight line with a velocity v. Okay. In this case, are we going to say that the particle is changing the direction? Well, since we are saying that it is moving on a straight line, we are not going to say that. If we ask that what is the angular velocity of the particle, I think we will all agree that it would be zero because the particle is just going on a straight line, so there's no angular velocity involved. But in this motion, you can notice that theta is changing. Okay, you can notice that it is not that the theta is constant. Okay, and even the r is changing. And let's say this is r1, this is theta1, and so on. All right, so this particular situation may be helpful to us in figuring out certain options, whether they're right or not. So let's go back and check the options. So the first option says the modulus of the angular velocity d theta by. So the rate at which this angle changes. How do we calculate this rate? So let's say if the particle, any particle is located at this position, and if let's say it is moving with a certain velocity, for example, let's say it is moving with this velocity, then we take two components of this velocity. What are those two components? We take one component along this line. Okay, and let me call it as v parallel, and we take one component perpendicular to this line. We call it as v perpendicular, and then the rate at which this line rotates. This rate is given by v perpendicular divided by this length, whatever it is. Okay, now keeping this in mind, let's check what the A option is saying. It says g theta by dt. Okay, so v sine phi minus theta. So if I extend this line, this angle becomes theta, and this angle becomes phi minus theta. Okay, so this angle becomes sine phi minus theta. So sine of phi minus theta will become what? See, if I say cos phi minus theta, so that will give me this component of the velocity. So sine phi minus theta will give me this component of the velocity, which would be perpendicular to r. Okay, so v sine phi minus theta divided by r. Yes, it is exactly the same thing that we said here, that v perpendicular upon l. So this option is correct. The modulus of angular velocity is d theta by dt. That is v sine phi minus theta by r. That is correct. Now modulus of tangential component of the acceleration. Now guys, notice this, that this r and second derivative, this is not exactly the tangential acceleration. Okay, because this gives you what? This gives you again the rate at which the speed is increasing in this direction, which may not be the acceleration or the rate of change of speed in this direction. Okay, so understand this, that our second derivative of theta will give you the acceleration, the component of acceleration, which is perpendicular to, in fact, not completely that, but this is certainly not the tangential acceleration. Okay, so this is not correct. Modulus of the normal acceleration is v theta. So again, guys, what exactly is normal acceleration? So normal acceleration is the rate at which the velocity vector is changing its direction. Okay. So if the velocity vector is like this at some instant, and in a short while it becomes like this. Okay. Then and this happens, let's say in time dt. Then the change in velocity vector would be this arrow. Okay. So when a vector rotates with some angular velocity, and let's say if the magnitude of the vector is constant, then the rate of change of that vector, the rate of change of a rotating vector is given by the magnitude of the vector into the angular velocity with which the vector rotates. Okay, so here also if we see that what would be the angular, what would be the normal component of the acceleration? So normal component of acceleration is responsible for a change in direction. Okay, so the rate at which v rotates, the rate at which this v vector is rotating would be given by v times the derivative of phi. Notice that the derivative of phi, not the derivative of theta, because as let me come back to this example. The theta is changing even when v is not rotating at all. All right. So the rate at which v rotates will be given by the derivative of phi, not the derivative of theta. So this is wrong and this is correct. All right. So out of these four options, A option is correct and D option is correct. B and C are wrong. And again, we can check this out. A option and D option are the correct ones. All right. Now, in this question, question number 18, it says a boy takes 60 minutes to swim across the river. Now, this is a classic example of the swimmer river problem. I would say the given situations, they are pretty easy. So, a boy takes 60 minutes to cross the river if the goal is to minimize time. So, when any swimmer or any boat is trying to minimize the time of crossing the river, let's say the river is flowing with a velocity u, then what does the swimmer or the boat does? They try to swim right directly towards the opposite bank, and as a consequence, they end up moving on a path like this. Like their orientation is always perpendicular to the two banks, but their motion is not along that direction. Okay, so they drift. All right, and this situation gives us the least amount of time, and that time is given by what? That time is given by the width of the river. Let me call this width as b, divided by the speed with which the swimmer can swim with respect to the river. So b by v. This is given to us as 60 minutes. So let me write this down. Okay, now the second case in which the goal is to minimize to zero the distance that is carried downstream. In this case, exactly how does the swimmer swims? So the swimmer breaks his velocity. That is the velocity with which the swimmer can swim. He breaks this velocity into two components. One velocity, the role of one component of the velocity is to neutralize the river velocity, and the remainder of the component. Now, remember, guys, the remainder of the component will not be v minus u. No, the remainder of the component would be, you have to calculate it vectorially. All right, so the remainder of the component would be root of v square minus u square, and this component will help in crossing the river. So in this case, how does the swimmer move, the orientation of the swimmer remains like this, and he crosses like this. Like this is the trajectory. All right. So the trajectory is perpendicular to the banks, but not the orientation in this particular case. So now the time to cross the river will be given by b divided by root of v square minus u square, and this is given to us as 180 minutes. All right. So let this be our second equation. Let this be our first equation. So if I divide equation number two by equation number one, I end up getting v by root of v square minus u square equal to 3. And now we can solve this equation. So it will become v square equal to 9v square minus 9u square, which basically means that u will be given by 8. U square, actually, u square will be given by 8v square by 9, or you can say that u will be given by root of 8 by 9 into v, which is 2 root 2 by 3 into v. So this is the relationship between u and v. Now we will use this relationship to check the options. So first option says that he can swim relative to water faster than the river current. So we can see that here 2 root 2. All right, 2 root 2 would be somewhere less than 3, and 2 root 2 by 3 will give us a number which is less than 1. So we can say that u would be less than v, which basically means that option A is correct. He can swim relative to water faster than the river current. Yes, this is true. He cannot swim relative to water faster than the river current. This becomes false now because it is directly contradicting option A. Now, if the width of the river is 3 root 2, the speed of the river current. Now, if the width of the river is 3 root 2 kilometer, so 3 root 2 kilometer divided by 60 minutes, or let me put it in hour only, so 1 hour. So that becomes the value of V. So V is 3 root 2. V is 3 root 2 kilometer per hour. Now, the question is talking about the speed of the river current, so we have to calculate the value of U. So let's go to this equation. So U was 2 root 2 by 3, and we just now calculated V to be 3 root 2 in this particular case. So 3 root 2. So this gives us 4 kilometer per hour. So option C is correct. Option C is correct. Now option D. If it crosses 3 root 2 kilometer wide river in this much. So if the swimmer is crossing 3 root 2 kilometer wide river in, we are assuming that the swimmer swims with his speed, which is this much, and the river current is also this much. And in this case, if the swimmer crosses 3 root 2 kilometer wide river, in now guys, here is a catch. Actually, here is something that is that we must take note of. So the river width is given to us, right? The river width, yeah, it is given to us as 3 root 2. So this is 3 root 2 kilometer wide river, and he is crossing it in 60 root 2 minutes. Okay, he is crossing it in 60 root 2 minutes. So the component of in this direction, the component in this direction can be calculated by using the given data. So let's say he has broken his velocity into two components, one of which is this direction, is this, and how much is this? So the distance covered divided by the time taken. Time taken is 1 root 2. Again, it is 60 root 2 minute. So if we convert that into hour, it will become 1 root 2 hour. So this becomes 3 kilometer per hour. So the swimmer could swim with a velocity of 4 kilometer per hour. No, the swimmer could swim with a velocity of 3 root 2. Here we calculated 3 root 2, out of which he has kept 3 kilometer per hour in this direction so that he can cross the river. What about the remaining two? So the remaining, what about the remainder of the velocity? Now, how much is the remainder of the velocity? The remainder of the velocity will again be 3 because the resultant of these two needs to be 3 root 2. And we are not sure this 3 can be in this direction or this 3 can also be in this direction. Now, if I consider the first possibility, let me call it as possibility A. In this case, the net velocity along the river current will become 4 minus 3, that is 1. Correct. So it will become 1 kilometer per hour. And how much time did he take to cross the river? He took 1 root 2 hour. So the drift would be in this much. The drift would be root 2 kilometer, and that would be downstream because 4 is greater than 3. So if the swimmer goes in this direction, he ends up like this. He ends up like this, reaching a point which is root 2 kilometer downstream. Now, the other possibility, what if the swimmer goes in this direction, like he keeps the other component of the velocity downstream? In that case, the orientation of the swimmer would be like this, and the swimmer would end up traveling somewhat like this. And how much will this drift be? This drift would be 4 plus 3, that is this 4 plus this 3, 7 into root 2. So this drift would be 7 root 2 kilometers. So according to the conditions given in option D, there are two possibilities of drift. One is root 2, that will happen downstream, and the other possibility is 7 root 2, which will also happen downstream. Now the question says that if he crosses 3 root 2 kilometer wide river in 60 root 2 minutes, he will be carried. Now, guys, strictly speaking, the question says that he will be carried this much. So this should be wrong because that is not the only possibility. There is another possibility also, and if that happens, then this statement becomes wrong. If it would have been he may be carried this much, then this would have been a right option. But I think the person who framed the question possibly did not think about the other possibility, and because this is given as the answer, like if he crosses 3 root 2 kilometer wide river in this much time, he will be carried. Okay, so It's not necessary. It was one of the possibilities, but it is one among the given answers. So the answer to this would be ACD, although D is a dubious option. All right. Now with that, let's go to the next question. It's a good question, guys. It says that this is question number 19. It says that two balls A and B are simultaneously released in two frictionless planes. Okay. Now there are two frictionless planes. The inclined have equal inclination. So if this angle is the okay, guys, I think the figure may not be visible to you. It may be hiding behind me. I'll tell you what the situation is here. So there is an inclined plane like this, and there is another inclined plane like this. Okay, there is, and both have the same inclination, and we are releasing a particle from here. We are releasing another particle from here. So A starts traveling like this, and B starts traveling like this. And after a while, we discover that they both have reached the same horizontal level at the same time. All right, this is what we discovered. So we have to now solve. Okay, guys. So if the situation is like this indeed, like they cross the same horizontal level simultaneously, then see this. The downward acceleration of this A particle, let be A. So the downward acceleration of this will also become A, and to be very clear, A will be equal to G sine theta. Okay, this is theta, so A will be equal to G sine theta. Although we will substitute this only when we are in need. I don't think we'll need it. We can work with A only. All right, so now the question next tells that in 12 seconds the particle reaches this level, and in 4 seconds this reaches this level. So this should be half a 12 square, and this should be half a 4 square. Let me check the times once again. It was 4 and 12 only. Yes. All right. So if this distance is x, if I consider this distance as x, the equation that I can write is half a 12 square minus x. That means this length will be equal to this length, which would be half a t square, and t is given to be 4. Okay, so from here we get the value of x as 72a minus 8a, which becomes 64a. So we now know the value of x. Okay, now if we already know the value of x, let's think about this. So this length is x, okay, and this is an inclined plane, this is another inclined plane. So one of the particles starts sliding down with an acceleration a, which means that the vertical acceleration would be a see this angle theta 90 minus theta. So it will become a sine theta, and this acceleration will become a cos theta. Similarly, this particle started sliding down. So if I take the components of this acceleration, how will it look? We will again a acceleration in this direction means a cos theta in this direction and a sine theta in this direction. Now, when we take a relative, notice that when we take a relative, the vertical components are downward and they are equal in magnitude, they get cancelled, and the horizontal components get added up. So it becomes 2a cos theta. So what we are now suggesting is that initially the particles were like this. One was here, the other was here with a separation of x, which is equal to 64a between them. And then what happened? Uh, if I consider the entire situation from the frame of particle A, then particle B started moving with a horizontal acceleration of 2a cos theta in this direction. So particle started moving like this with an acceleration of 2 cos theta. And when would be the minimum distance between the two? The minimum distance would occur when B becomes vertically below A, which basically means that the displacement of B is this length. How much is this length? This angle was theta, so this would be x cos theta. So the equation that we will write would be x cos theta is equals to half into a relative, which is 2a cos theta into t square. So this is the equation that we are going to write. Cos theta gets cancelled. Okay, x can be written as 64a. 64a, a also gets cancelled. So t square will become equal to 64, which means t will be equal to 8 second, which would be the answer. So the correct answer to this question is 8 seconds. I hope you like this question. I hope you enjoyed this. Question number 20. Interesting question. This question says that this wedge has started traveling with some acceleration A. Now, guys, imagine a situation in which this wall is not there and we have a rigid structure like this. Like there is a wedge and we have rigidly attached a horizontal rod on it, a horizontal bar on it. Imagine this. We have rigidly attached a horizontal bar on this. Okay. Imagine this. Now, uh, see, we actually have a wall here. We actually have a wall here. And this wall is what it is doing. It is melting 1 millimeter per second. So instead of imagining a wall which is melting this bar at the rate of 1 millimeter per second, you imagine that there was a hole in the wall and this bar is going inside that hole. This bar is going inside that hole at the rate of 1 millimeter per second. Notice that it doesn't change anything. All right, you can imagine a wall there which is continuously melting the bar because of which the bar is traveling rightward, or you can imagine a hole there in which the bar is entering at the same rate. Okay, so we can say that the role of this wall can be converted. into the roll of a hole, which is allowing the bar to enter it at the rate of 1 millimeter per second. So if this is going at the rate of 1 millimeter per second, okay, and uh, this will also have a vertical component. Actually, this is a horizontal component that we have fixed. It may also have a vertical component, let's say Vy. All right, but the wedge, okay, the wedge will move like this only, and the velocity of the wedge will be given by acceleration of the acceleration of the wedge into the time. Okay, so this is how the velocity of the wedge will be given by. Now, if I write the wedge constraint, that means the velocity along the normal should be equal for the wedge and the bar. So the velocity component of wedge would become this angle would be 90 minus theta if this angle is theta. So it would become V cos of 90 minus theta, which is sine theta. So V sine theta is equals to, now this Vy will have a component in this direction. This angle was 90 minus theta, so this will become theta. So we will write Vy cos theta plus, this is 1 millimeter per second. So keep that in mind that we are writing the velocities in millimeter per second. Okay. So 1 into cos of 90 minus theta. So that's sine theta. Now, how much is V? V is A into T. A is 0.5. So this will become 0.5 T sine theta is equals to Vy. Okay, or you can say that Vy we can replace. So it will become minus sine theta. Okay, uh, is equals to Vy cos theta. Check this out. Theta is given to us as 37 degree. So Vy will be equal to 0.5 T into tan theta. Tan 37 is 3 by 4 minus again tan theta. So tan theta is 3 by 4. Let me just check whether the calculations are correct or not. Yeah, seems correct. Okay. So now Vy becomes what? Vy becomes 3 by 4 and then 0.5 t minus 1. Now, if you notice this function Vy at t equal to 0, okay, at t tends to 0, Vy was negative, that means downward. Okay, at t equal to 2 second, Vy becomes equals to 0, and for t greater than 2 seconds, Vy become positive. So basically, this bar goes down initially, and then at 2 seconds it comes to rest, and then it again goes back up. So this is something is happening in this bar. Now let's read the options. The bar first moved downwards and then upwards. Yes, this is correct. Okay, so this is correct. The bar stops movement stops for a moment after 2 seconds from the beginning. So this is correct. Modulus of the displacement of the bar in the first 4 seconds. Okay, so we want to know what happened to the bar in the first 4 seconds. We want to know actually about the vertical displacement. So Vy can be written as dy by dt is equals to 3 by 4 into 0.5. Okay, 3 by 4 into 0.5. Hmm. Yeah, we were looking for derivative, right? Sorry. Um, dy by dt will be written as exactly how it was written. That's 3 by 4. So that's 3 by 8t minus 3 by 4. And now we'll bring dt on the other side and then we will integrate. Okay, so y is equals to 3 by 8t square by 2 minus 3 by 2. Check this. Okay, so at t equal to 3 by 4. I'm sorry, guys. 3 by 4t. At t equal to 0, y was 0, or whatever was the initial position, we can consider to be as 0. So this becomes 3 by 16t square minus 3t by 4. If I substitute t as 4, okay, then we get y as 3 minus 3, which is 0, which basically means that it went down and came back to the same level after 4 seconds. So the displacement, modulus of the displacement is 1.5. This is wrong. Okay, now the distance traveled by. Now we are talking about distance traveled, not the um, displacement, but we have already checked that the displacement in the same direction was 0, which basically means that it went down for 2 seconds. And at 4 seconds, it was again at the same position. Then it must have climbed up back again in 2 seconds only. Okay. Uh, all right. So how do we calculate this distance? We will calculate the displacement in 2 seconds and then we will double it. So how do we calculate displacement in 2 seconds? You integrate the same expression, but instead of putting the limit as in this expression, you change t to 2. Okay, so it will become y is equals to 3 by 16 into 4 minus 3 by 2 into 4. Check this. No, not 4, 2 seconds. We are calculating after 2 seconds. Okay, 3 by 16, it was 2 square, therefore it was 4. Okay, now how much does it become? So this becomes 4, so 0.75 minus 1.5, so that is minus 0.75. Minus indicates that it fell down, so 0.75 it fell down, 0.75 it will go up. Okay, because the displacement was 0 after 4 seconds. So the option says distance traveled by the bar in the first 4 millimeter is 1.5 mm. So 0.75 plus 0.75 is 1.5 mm. So yeah, this is correct. Okay. So finally, which all options are correct? D is correct, and then uh, yeah, D is correct, A is correct, B is correct, C is wrong. So A, B, D should be the answer. So A, B, D is the answer, as we can see. I hope you like this question, guys. I'll see you in the next question now.